In this video, we are discussing the example problems given in your textbook in page number 297 and 295. And both of these are related to the preparation methods of haloalkanes and haloarenes. The first one is identify all the possible monochloral structural isomers expected to be formed on free radical monochlorination of this particular compound. So basically, we have been given this compound, that is 1,2-methyl-butane, and we need to figure out what are the various monochlorostructural isomers that are formed when a free radical monochlorination takes place. So when free radical monochlorination happens, one of the hydrogen atoms gets replaced. That's how we get the monochloro compound, and that is the hydrogen is going to get replaced by a chlorine. So let's start with, so we are going to number these carbon atoms as 1, 2, 3, and 4. And as practice, I'm also going to be discussing the names of these compounds as well. So when you have the first carbon, it becomes CH2, Cl, CH, CH3, CH2, CH3. So the numbering stays the same. So it's 1 chloro, 2 methyl, butane. Next, when you have the second carbon having one of the hydrogens getting replaced by the chlorine atom. So CH3, C, Cl, CH3, CH2, CH3. If you wish to, you can pause the video at this point to write the name of this compound. So the numbering again stays the same. This is 1, 2, 3, 4. So 2 chloro, 2 methyl, butane. Next, you have the third carbon atom. One of the hydrogen atoms is getting replaced by a chlorine atom. So CH3, CH, CH3, CH, Cl, CH3. Now, in this case, we might have to change the numbering, because when we have a chlorine and we have a methyl attached to the main chain. So the priority goes to the chlorine atom rather than the methyl group. So the numbering becomes 1, 2, 3, and 4. So 2 chloro, 3 methyl, butane. And the last one, where you have the fourth carbon atom over here, one of the hydrogens is getting replaced by the chlorine atom. So CH, CH3, CH2, CH2, Cl. So this becomes 1, 2, 3, and 4. The same reason as the above. We want the chlorine atom to get lesser, the carbon attached to the chlorine atom to get a lesser number, the least number possible. So the molecule's name is going to be 1 chloro, 3 methyl, butane. Now you could be wondering, like, we considered the main chain, why are we not considering the hydrogen atom attached to the attached methyl group as well? And we're going to write that too. So CH3, CH, CH2, CH3, and then CH2, Cl. Now, since this carbon atom is actually attached to the chlorine, we are going to try and bring it to be a part of the main chain. So automatically our chain goes from being just a straight one to this. Okay, so here the name of the compound will be 1, 2, 3, and 4, right? So 1 chloro, 2 methyl, butane. which is exactly what we wrote over here as well. And because of that, we don't have to consider the attached methyl group. The next example is 10.4. We need to write the product of the following reaction. Now, it's pretty obvious that it's an alkene. All three of them have a double bond in them, and it's reacting with a hydrogen halide. So, this is a basic example of a Markovnikov's and an anti-Markovnikov's addition. So, according to Markovnikov's rule, the negative part of the reagent gets attached to the carbon atom having less number of hydrogens. So, hydrogen atoms. So, in this question, you have these two carbon atoms, a part of the double bond, and this one just has, the first carbon just has one hydrogen atom attached to it, whereas the second one has two hydrogen atoms attached to it. Now, according to Markovnikov's rule, the negative part of the reagent will get attached to the carbon atom having less number of hydrogen atoms. So, the negative part of the reagent over here is bromine. That is the bromine atom. And so, it will get attached to the first carbon, whereas the hydrogen will get attached to the second carbon. All of the reasoning as to why Markovnikov's rule and anti-Markovnikov's rule makes sense was discussed last year, and I would highly recommend you to go check that out because it makes it all the more easy to solve such questions. So you have a benzene ring, and to this carbon you have a bromine attached to it, whereas this carbon has hydrogen atoms attached to it. Or we could also write it as CH, CH3, Br. That's it. The second one is this, the same principle applies to this one as well. Excuse me. So here chlorine is the negative part of the chlorine, that is Cl minus is the negative part of the reagent. And here you have a carbon atom having just one hydrogen, whereas this one has two hydrogen atoms. So chlorine will get attached to this one, whereas the hydrogen is going to get attached to this one. So CH3, CH2, CH, CH3, Cl. That's it. And the last one is they have added another word called peroxide to it, which means it's the opposite of Markovnikov's rule, which means again here the bromine, according to Markovnikov's, it should get attached to the carbon having less number of hydrogen atoms. Whereas because of the presence of the peroxide, there is obviously a difference in the type of mechanism that takes place. And because of that, you have the bromine getting attached to the carbon having more number of hydrogen atoms. And remember, the peroxide effect is applicable only to HBr. It's not applicable to like HCl and HI. So CH2, CH2, Br. So that's it. And both these questions were related to what you've learned last year. You do not have to go back to it and like learn it thoroughly, but it's a good idea to have a basic knowledge of whatever you learned. In the next video, we'll be discussing the in-text questions related to preparation of haloalkanes and haloarenes.